In last class, we have studied about pinacol rearrangement. Today, we are going to learn about another rearrangement, that is dienone phenol rearrangement. And this is also an acid catalyzed rearrangement. What is dienone here? We'll be talking about 4,4 dialkyl, 4,4 dialkyl hexadiene none. So how will it look like? This looks like this. This is the structure, and when in the presence of an acid, we can take H2SO4, we can take any other strong acid over here. So in the presence of acid, it will get converted into phenol, and the migration of R group will take place. This rearrangement is called as dienone phenol rearrangement. Now we will understand how the mechanism of this reaction works. Instead of taking R and R, I'll be taking CH3 and CH3, or I can take both the R groups as same, doesn't matter. So let's take an example directly and then try to understand the mechanism. So assume I have taken CH3 and CH3 over here. So it is 4,4 dimethyl hexadiene one. Okay. Now I have treated it with H plus. Now when it will come in contact with H plus, this H plus will get attracted toward this oxygen lone pair and will form an alkylated alcohol like this. Right? And now to get rid of this plus charge, what will happen? This oxygen will break one of the bond with the carbon and will pull the electron density toward itself, which will lead to the formation of positive charge on this carbon. So this will look like this. This will become alcohol. A plus charge will form over here. This and CH3. Now as soon as this plus charge will form over here, this plus charge will start participating in the resonance. How? This bond will break. The electron density will come on this carbon and the bond formation. Let's number the carbons 1, 2, 3, 4, 5, 6. I number it every single time because it helps us in understanding the scenarios better. It helps us in keeping a track of the reaction, how it is going. So bond between second and third carbon will break. Electron density will be shifted towards 2. 2 and 1 will form a new bond. Okay, and the positive charge will get shifted to third carbon. So how the rearranged thing will look like, or how the resonating structure will look like, this will be OH, double bond here, plus charge over here, CH3, and a pi bond over here. Now after this, what will happen? Now this plus charge will again try to settle down itself. It will try to rearrange itself so that it can be a better stable carbocation. So now we will shift this plus charge over here and the CH3 will shift on this position. So basically 1,2 methyl shift will take place and the plus charge will shift on the adjacent carbon position. So it will look like this. Plus here, one CH3 over here, another CH3 over here, and OH. Right? Now on this carbon, we already have a hydrogen also. And if somehow this hydrogen comes out, the ring will become aromatic and this whole molecule will gain the aromaticity, which will make it highly stable. So in next step, the bond breakage between carbon and hydrogen will take place. So basically, removal of H plus will happen and the compound formed will be this. So again CH3, we have got a phenol and CH3 had rearranged itself in such a way that the shifting or migration of the CH3 has happened from the fourth position to the adjacent position. This is our alkylated phenol. Right? And this rearrangement is called as dienone phenol rearrangement. So in this case, what we have seen, that the CH3 is present over here. This CH3, so on the fourth position we have two CH3s present over here. There is a ketonic oxygen here. H plus will attack on it, will form a positive charge or alkylated alcohol over here. To settle down its positive charge, the bond between carbon and oxygen will break. one pi bond between carbon and oxygen will break and plus charge will form on the first carbon. Now this plus charge will resonate in the ring and the bond between first and second carbon will form, plus charge will shift on to the third carbon. Now the CH3 will shift on the carbon number 3 so that we can get a better stable carbocation, and the plus charge will shift on the fourth carbocation. So this is what we will get. Now we will, if we shift or if we break the bond with the hydrogen from the adjacent position, in that case we will get an aromatic ring which will make the molecule highly stable. Hence the bond between carbon and hydrogen will break and we will get a pi bond over here, and we will get the H plus back which we had taken initially to initiate the reaction, and that is why this reaction is called as acid catalyzed reaction, because acid which initiated the reaction, we have the H plus which has initiated the reaction, we have got it back in the system. Now here it really doesn't matter which R group we are shifting because both the R groups were same. But if we have two different R groups over here, we will have to check which group will migrate, and the group which will increase the stability of the plus charge will stay on the fourth position and other group will migrate. So we will see some other examples to understand this dienone phenol rearrangement where we have two different type of R groups present over here. Okay, let's see the next example. Now let's see the next example where both the R groups which are present on the fourth position will not be same. Let's say we have taken CH3 and let's say C2H5. I can write C2H5 as CH2 and CH3. Okay, now the same process which we have done before, the same process I'll do. H plus will attack on oxygen forming the protonated alcohol, hence converting it into this kind of molecule. This is the protonated alcohol, right? And now what will happen? This oxygen will break its bond with carbon so that it can regain its pair of electron, and the plus charge will shift on this carbon. This is the carbon number 1, hence forming CH3, CH2, CH3. Right? Now what will happen? Again this bond will break in such a way so that resonance can start happening. Now the bond between carbon 1 and carbon 2 will form, and the bond between carbon 3 and carbon 4 will break, and hence forming this. Now we have got a carbocation here, so the carbocation shift will happen. Now we have two groups over here, one is methyl and one is ethyl. So which group should shift? The group which is contributing less in stabilizing the plus charge. So if the plus charge will shift over here, if CH3 stays, it will give you 3 hyperconjugating structures, will make this carbocation much more stable as compared to this one, which will give only 2 hyperconjugating structures. So ethyl will give 2 hyperconjugating structures, whereas methyl group will give you 3 hyperconjugating structures. Correct? So which group will shift? This ethyl group will shift because it is not contributing as much as CH3 is contributing in the stability of carbocation. And now after the migration, the molecule will look like this. So CH3 plus charge over here, CH2 and CH3. This is how it'll look like, and I had told you in the previous example also that there will be a hydrogen present here which will break its bond and removal of H plus ion will take place so that there can be a double bond formation here. So the resultant molecule will be, so bond between hydrogen and carbon will break, forming CH2, CH3, CH3 and a double bond here, right? So this is how the migration will happen of a group when there will be 2 different groups present over here. So you have to see plus charge should stay with that group which will make it much more stable, or which will make the carbocation more stable. Okay, so we have many other good examples to discuss for dienone phenol rearrangement. I'll write down some examples, I'll write down some questions, try them on your own, and then we will discuss the solutions, and those questions will give you much more clarity about how to apply this concept. Okay.